Alright, so here's a pretty standard SAC question. We've been given some information to start with, and you're asked to show a few things. So if we read through the question, it's someone's designing a slide, and it starts at 0, 2 and 3.5, 0.25. So that would be this point here, which is very hard to show on here, and this other point here, which is 3.5, 0.25. So that would be this one here, and the other one, which I had in pink, was this point here. Alright, now this is the family of curves y equals ax to the power of n plus b, where n is an element of q, which is a fancy way of saying it's a fraction or a rational number. Now this is the key information that I missed the first time I saw this. The maximum gradient is 0.75, and so this means that if you look at the graph, between here and here, for example, all along there your maximum gradient is 3/4, but it is obviously negative. If you put a ruler to it, you can see it's a negative gradient. And so at the start it has a gradient of 0, and at the end you have to assume that it's at maximum gradient, which is 3/4. So we must assume that the gradient is equal to negative 3/4 at this point here, and that's your key information. So the first part of the question is pretty straightforward. It's just ask you to find the midpoint, and you can do that yourself. That's pretty straightforward. You find the midpoint between 0, 2 and I think it was 3.5 and 0.25. So I'm going to write that in fraction form. So that's pretty easy. The hard bit I found was this section here, where you asked to show that the power is the power is n over 2, and so we have this given to us, and you've basically had to show that a was negative 0.378, b was 2, and n was 3 on 2. So the first thing we pick up is the pink information, the 0, 2. So at our pink point 0, 2, we would substitute in 2 equals a x is 0, and the rest stays the same. That becomes 0, so we have b equals 2. So that's our first conclusion. And because it's asking you for correct to 2 decimal places, we would write it as b equals 2.000. Okay, that's the easy bit. Then you use the blue point, because that's the first part of the graph, and you take the information that the coordinate is 7 on 4 and 1 and 1.5, which is 9 on 8. So there's 2 pieces of information you obtain from the blue point. The first point is from the y equals ax to the n plus 2 situation. We use that b is 2 already, so we can use that. And we plug in 9 over 8 equals a bracket 7 on 4 to the n plus 2. And that gives us an expression for a in terms of n, or vice versa. So if we take away 2, we subtract 16/8, so it's negative 7 on 8 equals a 7 on 4 to the power of n. And we can rearrange that so that a equals negative 7 on 8 bracket and you want to get rid of the 7 on 4 to the power of n, so you could basically multiply by the flipped over version, which is 4 over 7 to the power of n, like so. And we'll call that equation 2. Then you go back to this point and use the derivative information. That should be a 9, not a 7. Okay. And so our derivative, dy dx, is the derivative, I'll go back to step 1. Our function is y equals ax to the n plus 2. And our derivative is dy dx is an x to the n minus 1. And the 2 just becomes a 0. So I've dotted in the plus 0, but you don't have to write it in. Okay, so now we use that the derivative is equal to negative 3/4 when x is 7 on 4. So that means we get rid of this x and turn it into 7 on 4. Okay, what's an easiest option for this? What I'm going to do is I'll just replace, so I'll call this equation 3. And we can substitute equation 2 into equation 3. So wherever I see an a, I will replace it with all of this in equation 3. So we have negative 3/4 equals, and we had a was negative 7/8 brackets 4 on 7 to the power of n, and then the rest we write out as before, so we have n bracket 7 on 4 to the power of n minus 1. Okay, so what's our first step? I would get everything that is in brackets out of the brackets, so I have negative 3/4 equals 7 on 8, 4 to the n, 7 to the n, and then this one here, I just write as 7 to the power of n, and then if you take away 1, you divide by 7, and then the other one is 4 to the power of n, and you take away 1 as a power, you get 4 up the top. I think that works. Okay, and so now what you have is your 7 to the power of n cancelling and your 4 to the power of n cancelling, which leaves you with numbers only and an n in the expression. Perfect. 7. Oh, and your 7s will cancel, which is handy. So I can get rid of them. And I can cancel down the 4 and the 8. So what would we have is negative n on 2 equals negative 3/4. Very handy. So now you get n by itself by multiplying by negative 2. So that gets rid of the negative and the 2, and that gives us 3 on 2. So that gives us our all our 3 values. So this is equation 4, and we can round that to 3 decimal places, 1.500. And then now you have equation 4, you can go back to equation 3. No, equation 2 actually. So we'll substitute equation 4 into 2. So equation 2 was this one. And we can find out A. Alright, so A is all this. And we can replace n with 3 on 2. So negatives, oh, I've got to keep the colours the same. So negative 7 on 8, 4 on 7 to the power of 3 on 2. And you can plug that into your calculator, it'll give you negative 0.37796, which rounds to negative 0.378. Awesome. Now let's get rid of this and go to the next bit. The next bit, oh, I didn't want to do that. Let's pick that up and put that over here. There. Okay, so the next bit says, show that the equation of the lower half of the sloping plane. So here's our picture. And the lower half of that, that's fine, I can get rid of this, is this part here, which I'm trying to highlight, but I'm failing. Oh, that's better. Okay, and so you got to show that the equation is that, but the first description says it's a transformation of the upper half. So if you look at it visually, and you have to be very astute about it, it's basically a rotation centered around this point, midpoint here. So if you turn that into dilations, reflections, and translations, there is no dilation. It's the same thing in terms of scale, but there are a couple of reflections. So you have a reflection this way that takes you to here, and there's a reflection that way that takes you to there. That way. And there is also a translation to the right, and there's also a translation up. Great. And there's no dilation, so that's fine. And those of you who are awake, you will notice that that point would have mapped to there, but then this upward transformation takes care of that, so it's all good. So our basic equation is still y equals ax to the n plus b. That's our first half, y1, and we know that a is negative 0.378, and we know our n is 3 on 2 now, and our b is 2. And I am being slack, I'm not giving you all 3 decimal places, but that's okay, you get what I'm doing. And so for this part, what do we do next? The easiest way of doing this, I think, is to do the transformations. So we've got a reflection vertically and a reflection horizontally, followed by a translation vertically and horizontally. It doesn't really matter which way. And so from y1 to y2, and from x1 to x2 as well, what happens, and it's going to annoy me, so I'll change the order. What happens is this point here, 0, 2, gets mapped onto this reflected point here, and then it gets mapped onto this reflected point here, and then that point shifts back up to this point. So our net result is that 0, 2 ends up landing on our endpoint, which is 7 on 2 and a quarter. That's our first point in yellow. The other point actually stays where it is throughout the transformation, and that other point is 7 on 4, I believe, and 9/8. 7 on 4 and 9/8, and they end up at the same point after all of the transformations. So we'll use that as a check. So if you look at your transformations, what you're going to have is you'll have first up your x. I'm just doing it one at a time. If we do the reflections first, you have a reflection in y and a reflection in x, so you're going to just switch the signs around. So that's your reflections times 2. There's 2 of them, this way and that way. And then there's also a translation, to the right and down. And so we're going to say it's negative x plus h and negative y plus k. And that's your translations. This way and that way. And so we use our mapping information, and we'll use the yellow information first. So we start with 7 on, so x dash is equal to minus x plus h, and the other yellow information is y dash is equal to negative y plus k. And so we know that our original number 0 goes up to 7 on 2 at the end, and so we can work out what h is, because h must be 7 on 2. Similarly with our y value, we started with a 2 and we ended up at a quarter, so negative 2 plus k, and so if we add 2 to both sides, you get k equals 2 1/4, which is 9 on 4. Is that right? Yes. And so here you can use the other point as a check. And how that works is you know that x dash equals negative x plus h and y dash equals negative y plus k. And so we start at 7 on 4 and we finish at 7 on 4. So therefore h must be 7 on 2. Similarly, we start at 9 on 8 and we end on 9 on 8. So k must be 9 on 4, which matches up with what we had before. Okay, so from this point on, if you use the transformations method, we start with y equals ax to the n plus b, and the transformed version, we just replace the x's and y's with the dashed versions. And so what we had was, instead of y dash, we have negative y plus 9 on 4. And instead of x, we had negative x plus 7 on 2. And so from before, we had a was negative 0.378. We had n was 3 on 2 and b was 2. And so if you rearrange that to make y the subject, what's the easiest way of doing this? I will subtract 9 on 4 first. That gives you minus a quarter. The rest stays as it was. Copy and paste as your friend. Let's do that. Excellent. And then I want to get y as a positive, so that means I have to multiply everything by a negative. So this changes this changes, and because you've multiplied one of these things, you don't have to multiply it twice by a negative. So you get positive 0.378. I'm going to rearrange these so that the 7 on 2 comes first, with a minus obviously. And this matches with the equation that we're given, except you have decimals instead of fractions. Okay, so that's the transformations way of getting it. And we did the check, which is fine. Alright, so that's how we've done that one.